Professor, his name is Professor Ball. He's actually, his lab is in that very north building that I'm telling you about. The building is called RAC, as in RAC for Research Advanced Center. That's what the three letters stand for. And we have two, RAC 1 and RAC 2. And he's a chemistry, and his experiments are in try to control the spin of particles, and how you can use, by controlling the spin of particles, you can actually encode information. So in regular zeros and one, like regular computers, you either have two states, either is on or off, 0 or 1, and depending on how many bits, the more bits you have, the more powerful the computer is, and so on and so on. But in particles, if you can then control the spin of a particle, let's say of an electron, and you can then properly control it, you can then put information in that angle. So if it's spinning like that, is one state. If it's spinning like this, is another state. If it's spinning like that, is another state. If it's spinning like this, is another state. If it's spinning like that, is another state. So you can have 6 possible combinations in one single bit, rather than only 0 or 1. So do you see how powerful then it can become? Like one computer, one 2-bit computer can already be, you know, a 24-bit or a 12-bit computer. Can you imagine now if you would have 64-bit computer, like, you know, or 128, like it's very typical nowadays, multiply that times 6 or multiply that times 8. And can you imagine, like, rather than only being 45, or you can actually control this angle, and each angle it's one state. So the possibilities to put information in that it's very large, and then that's why it's so powerful. So he actually has that kind of spearheading that kind of what's called Spintronics. His lab is called Laboratory of Spintronics, because that's exactly what he's trying to control, is the spin of particles.
There's actually another